Imagine a world where the sky is the color of rust, the sunsets are blue, and the ground is littered with the bones of an ancient planet. It's a place of silent, crushing cold, bombarded by cosmic rays, where the very dirt is toxic. For centuries, we looked at that world, a steady red pinprick in the night sky, and we wondered. We named it for a god of war and wove it into our myths and our fears. But the question was always the same, whispered across 100 million miles of emptiness. Is anyone out there? Are we alone? Now, for the first time in human history, we are there. We have touched that alien soil, and the answers we're finding, they're rewriting the story of our own home and forcing us to ask a new, even more profound question. What if we're not the first life the solar system has tried to make? What if Mars was once alive? This is the story of our robotic pioneers, our eyes and hands on a world just next door. It's a detective story written in rock and dust, told by a handful of machines we've sent on an impossible journey. It's the story of what we've found on Mars, and what it means for us, and for the future of everything we know. The journey to really understand Mars didn't start with a rocket launch. It started with a telescope, and a whole lot of wishful thinking. In the late 1800s, an astronomer named Percival Lowell stared through his lens and saw what he believed were canal-engineered waterways carrying precious liquid across a dying world. He sketched them, wrote books about them, and convinced much of the public that an intelligent, desperate civilization was fighting to survive on the red planet. It was a beautiful, thrilling idea, and it was completely wrong. The canals were an optical illusion, a trick of the eye and the mind, stitching together faint surface features into a pattern that made sense to us, but that mistake lit a fire. It planted the idea that Mars wasn't just a point of light, but a place, a destination. The first Mariner flybys in the 1960s shattered the canal myth forever, showing a cratered moon-like wasteland. The air was thin, barely there. The place looked deader than dead. But then, in 1971, Mariner 9 arrived to find the entire planet shrouded in a global dust storm. As the storm cleared, a geological wonderland was revealed. Not canals, but something real and breathtaking. Canyons that dwarf our Grand Canyon. Volcanoes so massive they would poke out of Earth's atmosphere. And most tantalizing of all, what looked like dried-up rivers, meandering channels, delta fans, basins that screamed of ancient floods of unimaginable scale. The question shifted. Maybe there were no Martians building canals. But maybe, just maybe, Mars had built something for itself. An environment, a climate, the conditions for life. That's when the real detective work began. And we needed to send our best investigators. We needed to go to the scene of the crime. Our first field agents were landers. Viking 1 and 2 touched down in 1976, a triumphant first. They were labs, designed to answer the ultimate question head-on. Is there life on Mars? They conducted biological experiments, mixing Martian soil with nutrients, looking for the telltale signs of metabolism, of breathing. The results were confusing. One experiment gave a positive signal, a burst of gas that looked like something was eating the food. But other instruments found no trace of the complex organic molecules that are the building blocks of life as we know it. The consensus became that the soil was just chemically reactive, mimicking life in a cruel cosmic joke. The official word was a heartbreaking no signs of life. Mars was declared a sterile, oxidizing desert. The case seemed closed for decades. But good detectives never let a cold case stay cold. They look for new angles. And our new angle was a simple, powerful mantra: follow the water. If life ever got started, it would have needed water. Liquid water. Not frozen at the poles, not locked in rock, but flowing, pooling, lasting for eons. So we started sending rovers. Not just stationary landers, but mobile geologists. Pathfinder and its little Sojourner rover in 1997 showed we could drive around. But it was the twin rovers, Spirit and Opportunity, that landed in 2004, that changed everything. Their mission was supposed to last 90 Martian days. Spirit kept going for 6 years. Opportunity, that unstoppable little machine, operated for nearly 15 years. And what it found was the case-breaking evidence. Landing in a small crater called Eagle, Opportunity immediately saw something incredible in the surrounding rocks. Cross-bedding, tiny, layered patterns that, on Earth, are only formed by flowing water. Then it found the blueberries. These tiny, spherical concretions of hematite scattered everywhere like cosmic ball bearings. On Earth, they form in water-soaked rock. This was forensic proof, not just a little water. This was a shallow, salty sea, an environment that, on our planet, would teem with microbes. Spirit, on the other side of the planet, found silica deposits that looked like the leftovers of a hot spring or a fumarole, a place where heat and water and minerals mix, another prime candidate for the cradle of life. The verdict was in. Mars wasn't always this dry, frozen crypt. Once, and for a very long time, it was wet. It had lakes. It had rivers. It had an atmosphere thick enough to keep that water liquid. It was, in a word, habitable. But habitable is one thing, inhabited is another. Did anything actually live there? To answer that, we had to send a much more sophisticated lab. We had to send Curiosity. Curiosity is a beast, the size of a small car. It landed in 2012 with a sky crane maneuver that still looks like science fiction. Its target, Jezero Crater, chosen because satellite images showed what was unmistakably an alluvial fan at the base of a central mountain, Mount Sharp. This was a place where water had clearly flowed and pooled for a long, long time. Curiosity didn't just look at rocks. It drilled into them, pulverized samples, and cooked them in its onboard chemistry lab, and the data started streaming back. First, it confirmed the water story in stunning detail. It found an ancient stream where the water flow was anchored to hip deep. It found a lake bed that existed for millions of years, maybe longer. This wasn't a flash flood. This was a stable, persistent environment. Then came the bombshell. In that mudstone from the ancient lake, Curiosity found the key ingredients for life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, all the fundamental elements. More than that, it found complex organic molecules. The building blocks were there, preserved for billions of years. It also found something else: the chemical fingerprints of chemical energy sources that certain microbes on Earth love to eat. Methanogens, for instance, could have thrived here. And here's the wild part. Curiosity detected methane in the Martian atmosphere. On Earth, over 90% of atmospheric methane is produced by living things. On Mars, it comes in mysterious seasonal plumes. It could be geologic, from water-rock reactions underground, or it could be something else. It's the most tantalizing, frustrating clue in the entire case. A whisper where we need a shout. The detective work is now focused on the most promising crime scene we've ever targeted, Jezero Crater. This is where our newest and most advanced geologists' perseverance is right now, as we speak. Jezero isn't just an ancient lake, it's a delta. We can see from orbit the clear fan-shaped structure where a river once deposited sediment into a standing body of water. On Earth, deltas are magnets for life. They concentrate organic material and are perfect for preserving its fossils or biosignatures. Perseverance is built for one job: to search for those signs of past life. It's collecting the most promising, carefully selected rock core samples, sealing them in pristine tubes, and leaving them in a cache on the surface for a future mission to pick up and bring back to Earth for the first time. We're planning a round-trip ticket to Mars. We're going to get these rocks into the best labs on our planet, with instruments far too large to send to Mars. We will hold a piece of that ancient, watery world in our hands. And Perseverance isn't alone. It brought a friend. Ingenuity, a tiny helicopter, proved that powered, controlled flight is possible in Mars's wisp-behind air. It was a Wright brothers moment on another world, scouting ahead and showing us perspectives we've never had. It's changed the game for how we'll explore in the future. Canyons, cliffs, caves, places rovers could never reach, are now within our sight. So what's the picture these tireless robots have painted for us? It's a stunning, tragic epic. Billions of years ago, Mars was a different planet. It had a global magnetic field shielding it from the solar wind. It had a thick atmosphere. Temperatures were moderate. Rivers carved canyons and tumbled down mountainsides. Rain fell. Lakes pooled in craters. Some scientists believe a vast ocean may have covered much of the northern hemisphere. This wet period may have lasted for 1 billion years or more. That is a long time. On Earth, it took less than half that for life to appear in our oceans. Then, catastrophe. Mars is small, about half the size of Earth. That meant its interior cooled faster. Its magnetic dynamo shut down. Without that protective shield, the relentless solar wind began to strip the atmosphere away, molecule by molecule. Like a cosmic sandblaster, the air pressure dropped. The greenhouse effect collapsed. The planet grew cold. The water on the surface either evaporated into space or froze solid, locking away its secrets in ice and deep aquifers. The world that was once so Earth-like became the freeze-dried desert we see today. It died. Which leads us back to the haunting question. In that billion-year window of opportunity, when rivers flowed under a pink sky, did something spark? Did the complex organic chemistry Curiosity found ever cross that unimaginable threshold and become alive? If it did, it was probably simple, microbial. Maybe it retreated underground as the surface died, finding refuge in deep, warm, wet rock. Maybe it's still there, hanging on. Or maybe it flared out, a brief experiment snuffed by the changing planet. This isn't just academic. This is deeply personal. Because if life started independently on Mars, just next door, then the universe is teeming with it. It means life is not a miracle. It's a natural process, a common feature of wet, rocky planets. We are not a singular, lonely accident. We are part of a cosmic fabric. Conversely, if we bring those Jezero Crater samples back and find them sterile, if we search every promising niche and find nothing, that is equally profound. It means that the step from chemistry to biology is not an easy one. It means this pale blue dot of ours, with its riot of life, might be more special, more rare, and more fragile than we ever dared imagine. The exploration is accelerating. The future is, frankly, mind-blowing. The next rover mission will be focused on bringing those samples home. But we're thinking bigger. We're talking about human footprints in the rust-colored dust. It's no longer a question of if, but when. The challenges are immense. The radiation, the isolation, the 2-year round trip, the need to live off the land. But the goal is clear. To have geologists, not just robots, chip away at the bedrock of Jezero, to have astrobiologists drill deep into the subsurface where any potential survivors might still cling to existence. We're also looking for the best place for a potential future home. Satellites like the Mars Reconnaissance Orbiter have found vast sheets of water ice just beneath the surface at the middle. That's not just a scientific target, that's a resource. Water for drinking, for growing plants, and for making rocket fuel. We are learning to be Martians, and the predictions, they get wild. If you find definitive proof of past life, it'll be the greatest discovery in human history. It'll reshape philosophy, religion, and science overnight. If we find current life, even a single dormant spore, it changes everything about our place in the cosmos. It also raises urgent ethical questions. How do we protect it? How do we avoid contaminating it with our own earthly microbes? Mars may have rights we have to consider. The silent, red world we once imagined as a home for warlike aliens has turned out to be something else. It's a mirror, a time capsule. It shows us a version of Earth's possible future, or a glimpse of its distant past. It's a warning of what can happen when a planet loses its protective shield and its climate collapses. And it's a promise that the universe is a place of astonishing variety and history, and that we, the curious, storytelling apes from the third rock, have only just begun to read its stories. We are all witnesses to this golden age of discovery. Every new image from Perseverance, every chemical analysis beamed back, is a page in a mystery novel we are writing together. The robots are our proxies, their steel wheels our feet, their cameras our eyes. They are out there right now, in the deep quiet, under a pale sun, sifting through the ashes of a lost world, looking for a single, precious ember. And the answer, whatever it is waiting, in the rocks, in the dust, in the ancient, silent valleys of Mars. We just have to keep looking.